Welcome to my Research Express. In this video, we will learn how to perform a principal component analysis in MATLAB. To illustrate PCA, we will use random matrices as a data for a simple example. Load MATLAB and generate two random matrices, each representing a different set of variables. Let's see these matrices. Matrix 1 contains 3 columns and 100 rows, or, as we called them, 3 variables and 100 observations. As well as matrix 2. These matrices are the 3D matrix since they have 3 variables, and if we plot them, they will look like this. The data in the matrix is in the 3D plane. Then what about matrices containing 4, 5, 6, or even 100 variables? Is there a 4D, 5D, or 100D plane? Of course not, because that would be very confusing. This is where PCA comes in. PCA plays a role in reducing data with many variables or dimensions to only 1 or 2 dimensions. Let's continue our lesson with the matrix containing just the 3 variables. Normalize the matrices by subtracting the mean to ensure optimal variance capture during PCA. Calculate the covariance matrices and perform eigenvector decomposition for both normalized matrices. Choose the number of principal components you want to retain. For example, let's choose 2 PCA. Transform the original data using the selected eigenvectors to obtain reduced dimensional feature matrices. Visualize the results. In this code, 2 subplots are created side by side. The left subplot shows the original data using circles for matrix 1 and crosses for matrix 2. The right subplot displays the PCA reduced data using circles for reduced matrix 1 and crosses X for reduced matrix 2. Labels and legends are added for clarity. That's all for this video. For a more comprehensive explanation and step-by-step guide, please go to the link in the description. If you find this video useful and helpful, please support me by clicking the like and subscribe buttons. Don't forget to ring the bell so you don't miss the other learning videos from my Research Express. Your gateway to data analysis mastery. Thank you for watching.